Hello, everyone. In this lesson, we are going to be learning about the fundamental theorem of algebra, specifically how it applies when you are given a complex root and you're asked to find all the other complex roots. One thing that you're going to notice is you're going to graph these functions, and you're not going to find a zero at all. I could zoom out. They don't cross the x-axis. But notice that its degree is 4. There should be 4 total roots, including real and complex. Everything should be 4. So that means all of your roots should be complex in this case. You're going to have 2 sets of complex roots. So on this paper, the question says, how many total roots does it have? Well, it should have 4 because that degree is 4, and it's always going to match that number. I graphed it. Are there any real roots? Absolutely not. They're all complex. How do we know? How are we going to find the complex roots? Well, I'm going to tell you, you're going to need to be provided one to be able to get the other one. So we kind of make it a puzzle. So I start with the complex root. I start with another one. I work them together, make my polynomial. I build it from the roots. So what I'm doing is I'm providing you one of those complex roots. Can you get the other 3? That's what our task is going to be today with all 3 of these. So in this question right here, it says, suppose we are told that x equals 2 minus 3i as a root. I'm giving you 2 minus 3i. So we're going to circle that. Now we're going to verify that it's a root by doing something on your TI-84 calculator that you may not know can be done. First thing is we're going to be working with the complex part of your calculator. So you are going to press the following: mode. You can't do this in Desmos, folks. This has to be done in one of these handheld graphing calculators. Go down to where it says real, change to a plus bi, press enter, hit clear. Take it out of there. Now you're in the a plus bi mode. We're going to take our complex root and we're going to substitute it in for all values of x. The way you do that is you put parentheses around what you're plugging in. Since our root is 2 minus 3i, you're going to type 2 minus 3 in parentheses. I is the second function of the decimal. So you'll hit second dot, and that's going to put an I there. Close the parentheses up. You have plugged in 2 minus 3i for x. It says to the 4th power, so hit the exponent button, put 4, and then hit the right arrow button to go back down. Do the same thing with all the other ones. I've plugged them all in. I can verify by scrolling to the right. Every value where x was, I plugged it in with 2 minus 3i. Kept the exponents, kept the coefficients, went all the way down to the end. Once you do that, drum roll, please. You're going to hit enter. You get 0, which means 2 minus 3i is actually a root. It gives you 0. These calculators can help you get complex roots or help you work with them. So now I can use that to get all the other complex roots. First of all, I got you guys got to know about the conjugate, okay? The conjugate, every time you have 2 minus 3i, then you're always going to have 2 plus 3i. So remember, all of these get a plus or minus with them. That's called a complex conjugate, 2 plus or minus 3i. Remember, they come in pairs, guys, pairs. So if I give you 5 minus 4i, 5 plus 4i will be another one. So what we're going to do is we're going to recognize that 2 of these 4 roots are simply going to be 2 plus 3i and 2 minus 3i. Still got to get the other 2 roots. We're going to have to use synthetic division using this, which is kind of hard. Here's how we do it. You set up your synthetic division with your coefficients, accounting for any gaps. 1, 2, 14, -2, -22, and 325 are going to be those numbers here. Now, this is not a number. That root is actually a complex value. So it's, in this case, 2 minus 3i. We're going to put it where we would plug in the number in synthetic division. We're going to operate with synthetic division like we would with any number, but you got to be careful with that 2 minus 3i. What we'll do, we'll bring that 1 down like we normally would. Put it there. Multiply. 1 times 2 minus 3i. Okay, 2 minus 3i. 2 minus 3i, that's not a number. No, but you can still put it there. And you'll put 2 minus 3i here. And you'll add down. Now, the I isn't going to get combined with anything. It's just 2 plus 2. So that's going to be 4 minus 3i. Now, could you add 2 plus 2 minus 3i in your calculator? Sure. 2 plus 2 minus 3i is 4 minus 3i. So I can use my calculator to help me do adding. It's going to come more in handy when you do the multiplication. All right, 4 minus 3i. Uh-oh. I got to times that by 2 minus 3i. Now, that can be done by hand. That's another lesson. I'm not going to teach that by hand, but you can certainly look at how to multiply those by hand if you're interested. I'm going to go straight to the calculator for this one, guys. So again, make sure you're into A plus BI mode. Type it like this. 4 minus 3i times 2 minus 3i. Just use parentheses around them. It's multiplication. Hit enter. That's your output. And remember that value will go right there. So now I have -1 minus 18. I'm going to add 14 to that. You can scroll up, highlight it, hit enter, bring that down so you don't have to retype it if you'd like. 14 plus -1 minus 18 is 13 minus 18. 13 minus 18i. Multiply again. 13 minus 18i multiplied by 2 minus 3i gives you -28 minus 75i. -28 minus 75i will get added to the -22. So -22, scroll up, press enter. -22 plus -28 minus 75i. -50 minus 75i is what you get when you add down. Remember, we're adding down here. At this point, you're like, why are you making this even more complicated? That's fair. It definitely looks more complicated. That's why they call it complex numbers. But you're gonna see something magical happen right here, guys. Brace yourself. All right, we're gonna take this -50 minus 75i. And I'm going to show you how I type that in so you can see it live. And then we're going to multiply it by the 2 minus 3i in the box. And you get -325. What happened to the i's? Guys, if 2 minus 3i is a root, then you should get a remainder of 0. So now I just made this more complicated, but what I'm going to do is I'm going to realize, hey, these come in pairs. So it's not 2 minus 3i, it's 2 plus or minus 3i. I got another root. I'm going to use that one in my next one. So I'm going to use what this is called. I'm going to write this down. It's called the conjugate. The complex conjugate means that I'm going to take the sign right to the left of the coefficient for I and change it. That's going to be my new complex number, my new complex root. So this is going to be 2 plus 3i. Keep the 2, but change this to plus. We're going to copy our new coefficients. Zero, that was our remainder, so we're not going to copy that again. We will now do our round of synthetic division one more time, okay? So going down for this one, we got, dropping down the 1 times 2 plus 3i is going to be 2 plus 3i. Oh, in this case here, I have an I with a 3. Oh, they're opposites of each other. What's going to happen? Oh, snap, guys. Those cancel out. So that's really just 4 plus 2. That's 6. 6 is going to get multiplied by 2 plus 3i. That's just distributing. 6 times 2, 12. 6 times 3i, positive 18i. Guys, those cancel out. I'm not just making this up. Look, 6 times 2 plus 3i. 12 plus 18i. It just distributes, y'all. So that i's cancel out. You're going to get 13 plus 12. Feel free to use your calculator to double check your work. That's 25. 25 times 2 plus 3i. 50. plus 75i. Cancel, cancel. Remainder of 0. But now I have my quadratic. This is my quadratic. My quadratic is 1x squared plus 6x plus 25. And we're going to set that equal to 0 and solve to get the other complex roots. So if you remember the quadratic formula, it's opposite of b, plus or minus square root b squared minus 4ac, air conditioning, all over 2a. That'll get you your other roots. In this case, those are going to be complex too because we didn't have any real roots. So we're going to identify our a. A is going to equal 1. B is going to equal 6. C is 25. Looks like they're all positive. So the opposite of 6 is negative 6. Plus or minus 6 squared minus 4. A is 1. C is 25. All over 2a. 2a, 2 times 1. 2 times 1. So all that gets plugged in. Let's work it out. Use your calculator to get this part right here if you need to. Remember, that's only what you're calculating. Don't type the square root. Always put parentheses around what you're squaring, especially if it's negative. Don't gamble with negatives. You will get, in this case, negative 64. We write our answer like so. Negative 6 plus or minus the square root of negative 64 all over 2 times 1, which is 2. You can square root 64. That's 8. In fact, if you're in mode where you are in a plus bi, you can actually square root of negative 64. I didn't tell you this the other lesson, but if you square the negative 64, it'll give you 8i. So this is going to end up becoming negative 6 plus or minus 8i, all divided by 2. Since both 6 and 8 are divisible by 2, your other complex solutions are going to be negative 3, because that divides by 2 to get 3, plus or minus 8 divided by 2 is 4i. These are your other complex solutions. So you have 4 roots in this problem. And those 4 roots are going to be 2 minus 3i, 2 plus 3i, negative 3 plus 4i, and negative 3 minus 4i. Let me list them all out here. So these are your complex roots. Four roots, 4th degree. We're good to go. Try the one on the back side. There's 2 practice problems. These are very time consuming. So I'm going to have you flip this paper over and make an attempt on this problem right here. I would like you to pause the video. I'm going to work it out faster this time because I've already gone through the mechanics of the previous one. So go ahead and pause the video. Try it on your own. If you're not listening and you're just watching, pause the video. Try it on your own. Here we go. I'm going to pause, work it out, and show you my solutions and walk you through my steps. Here's the synthetic division part. I wrote the minus 3 minus 2i, 1, 4, 8, 16, 91 for my coefficients above. Next, I went down, dropped the 1, multiplied, rewrote, added these together because this is just going to be minus 2i. So that's 1 minus 2i. I used my calculator for this part. You can see up here. 1 minus 2i times negative 3 minus 2i will give you negative 7 plus 4i, which goes there. Add that down. That's just going to give you 1 plus 4i. And then I multiplied again times negative 3 minus 2i to give me this. Added down, that's 21 minus 14i. Multiplied by negative 3 minus 2i to give me negative 91, 0. Drop these 4 down. Write my conjugate. Remember, this is going to be, if that's a minus, that's going to be 1 with a plus. These 3's will stay negative because we don't mess with the real number. We just mess with the complex, the imaginary number. Drop the 1 down, multiply. I'm just multiplying by 1, so these will cancel. That's negative 2. Multiply. That's positive 6. And that should be a minus 4i because those will cancel that out. That's going to give you 7. 7 times negative 3 is negative 21. and 7 times 2i is 14i. As you can see, those cancel out, give you 0. Pause the video, solve it using the quadratic formula to get your other complex solutions. I identified my a, b, and c, 1, -2, and 7. I plugged them into the quadratic formula. The opposite of a negative is a positive, so 2 plus or minus the square root. You see how I'm using parentheses around my -2. -2 squared minus 4 times 1 times 7, all over 2 times 1. Calculate the number inside of the square root. In this case, it's -24. When you have a negative under the square root, it's going to give you an I, but you can't square root 24. We do not want to write, even if you're in A plus BI mode and you type -24, you're not writing a decimal for this. So we're going to write this as 2 plus or minus I squared of 24, all over 2. Now, that's an acceptable answer for me right now. You are encouraged to reduce that radical. In order to reduce a radical, list the factors of the number inside the square root. Find the highest number that can be square rooted. In this case, 4 times 6, 4 can be square rooted. So we're actually going to rewrite this as this. I'm going to put this over here, and I'm going to rewrite this as 2 plus or minus I times the square root of 4 times 6, all divided by 2. The special thing about that is you can square root 4. The square root of 4 is 2. So that 2 is going to get put on the outside, and it's going to become 2 plus or minus 2i square root of 6 over 2. Now you can see both of these terms are divisible by 2. So 2 divided by 2 is 1. 2i divided by 2 is I times the square root of 6. So these are 2 of your complex solutions. Your other 2 are going to be -3 plus or minus 2i. That is how you do this. So your assignment, you have seen these 2 examples. I'm just going to give you that one, and you're going to try it. I'm not going to put my example on the video here because I want you to try this on your own. But you can certainly check with your teacher if somebody else is helping you out, or with me in class if you're in my class. Thank you for watching. Have a great rest of your day.